Hello students, this is Sudhir Shukla. Hope you are well. Dear students, let's start our discussion for the topic GPS navigation message. GPS navigation message. Dear students, in our previous discussion, we have covered that what is GPS. Actually, we have started for various satellite systems through which we have covered the first satellite system, that was VSAT, very small aperture terminal. The second, we have covered DBS TV, direct broadcasting satellite television, and the third we have covered this GPS, global positioning system, in which we have come to know the introductory part, basic part, development, technical structures, application of it, GPS receivers, codes, all of those things related to that of global positioning system. So students, let's have a look for this GPS navigation message. So generally, if I say the GPS satellites transmit two microwave carrier frequencies, two microwave carrier signals. First, the L1 frequency, that is 1575.42 megahertz, carries the navigation message and the SPS code signal. The second one is the L2 frequency, that is 1227.60 megahertz, is used to measure the ionosphere delay by PPS equipped receivers. Dear student, that means जिस GPS सैटेलाइट रिसीवर की हम बात करते हैं, that basically consist of the two signals. That means जो GPS satellites होते हैं, they transmit two microwave carrier signals, of which the L1 frequency, that is 1575.42 megahertz, carries the navigation message and the SPS code signals. The L2 frequency, that is 1227.60 megahertz, and is used to measure the ionosphere delay by PPS equipped receiver. So the positioning information from GPS satellites is sent in the form of repeating codes, जिसको हम आइडेंटिफाई करते हैं through the sending satellite, and that give locations of the other satellites in the system, and also it gives the navigation data. So the codes which form the GPS signal structure are superimposed upon two carrier waves in the L band frequency and frequency range set aside for satellite communication. So both the carrier frequencies and the signal frequencies are derived directly from the onboard atomic clock oscillator frequency of 10.23 MHz. So the coded signals are repeated regularly in epochs on the order of 15 seconds. The codes used are known as pseudo-random codes. The codes are well suited to decoding a message embedded in a noise signals which may be orders of magnitude larger than the signal itself. So such techniques were valuable in picking up radar echoes of the moon and asteroids. So use of these codes facilitates the sorting out of signals which arrive simultaneously from several GPS satellites. So the navigation message is a 50 Hz signal consisting of data bits that describe GPS satellite orbit, the second one is clock corrections, the third one is other system parameters. That means जो navigation message की हम बात करते हैं which is at 50 Hz signal that consists of data bits and that basically describes GPS satellite orbits, clock corrections, other system parameters. So these are the 3 points which is basically described by the data bits of a navigation message at 50 signal hertz frequency. So the next one is structure of the GPS navigation data. Structure of the GPS navigation data. Structure of the GPS navigation message data. So in this, the user has to decode the data signal to get access to the navigation data. The user has to decode the data signal to get access to the navigation data. So for online navigation process, the internal processor within the receiver does the decoding. So most of the manufacturers of a GPS receiver provide decoding software for post processing process. So let me draw the structure for navigation data. So it is 1, 2, 3, 4, 5. Zero, 1, 2, 3, 4, 5, 6, 7, 9. See, that is one. Steer. So this is 1, this is 2, comma 3, and likewise 4, 5. So this is subframes. This is data block 1, clock parameter. This is data block 2, broadcast ephemeris. This is data block 3. This is almanac UTC, ionosphere, spatial formation. So this is basically a figure, that is structure of navigation data. Got it? So when a bit rate of 50 bit per second and a cycle time of 30 seconds, so the total information content of a navigation data set will be 50 bits. That is 50 bits per second and a cycle time of 30 seconds. So the total information content of a navigation data set will be 1500 bits. So the complete data frame is subdivided into 5 subframes. 1, 2, 3, 4, 5 of 6-second duration, comprising 300 bits of information. Let me write, this is data frame, this is subframe, and this is information control. This is information control. So each subframe contains the data words of 30 bits each. 6 of these are control bits. The first two words of each subframe are the telemetry work, that is TLM, and the C by A P code handover work, that is represented by HOW. And the TLM work contains a synchronization pattern which facilitates the access to the navigation data. So generally the navigation data record is divided into three data blocks. Data block 1 that appears in the first subframe and contains the clock coefficient bias. That it appears in the first subframe and contains the clock efficient bias. This is what a data block 1 what I have mentioned here. The second one is data block 2. So this appears in the second and third subframe and contains all necessary parameters for the computation of the satellite coordinates The data block 2 that it appears in the second and third subframe and that contains all the necessary parameters for the computation of the satellite coordinates. Now data block 3. This data block 3 that appears in the fourth and fifth subframes and contains the almanac data. With clock and ephemeris parameter for all the available satellites of the GPS system. So this data block includes also ionosphere correction parameters and particular alphanumeric information for authorized users. Alphanumeric information for authorized users. So dear students, unlike the first two blocks, the subframes 4 and 5 are not repeated every 30 seconds. So this is all about the GPS navigation message. I hope you understand the structure of navigation, blocks associated with it, and seriously just go through this video because objective questions may be asked from these points what I have mentioned here. So I hope that you will go through these points. So thank you so much for today's discussion.